Good morning friends, I welcome you all in this session. In this session we will discuss a numerical which is based on probability models. So, let us look at a network which has got total 11 activities and these are different time durations of those activities. Activity 1, 2 has normal distribution with optimistic time as 3 days, pessimistic time 9 days. Activity 2, 3 again a normally distributed activity with optimistic and pessimistic times given here. Activity 3, 9 normally distributed with optimistic and pessimistic times. Similarly, you have got activity 5, 8 has a constant duration. So, when you have got constant duration of an activity, it will not have any standard deviation, right. So, the constant duration of this activity, activity number 5, 8 is 5 days. Similarly, activity 8, 9 again constant duration, its duration is 4 days. Activity 3, 4 is a dummy activity in this project. Let us look at the time durations of other activities in this network. So, there is an activity T 4, 5, right. So, this is activity T 4, 5 and the probability that it would take 3 days is 0.2, it would take 4 days 0.3, it would take 5 days 0.4 and it would take 6 days 0.1. So, the sum of this probability is 1, right. Similarly, for activity 1, 4, 6, 7 and 7, 8, right. Now, this is the network for which we have just discussed different time durations, right. So, what we have to do in this question? Find critical path and variance along critical path. This is the first part of the question. The second part is what is the probability that the project will be completed in less than 40 days. So, we will start solving this particular network and we will find out what is the probability that the project would be completed in less than 40 days, right. So, let us get started and we will find out first critical path, right. So, first of all you need to calculate the expected duration of all the activities, right. So, if you look at the first activity which is activity 1, 2, activity 1, 2, right. So, optimistic time 3 days, pessimistic time 9 days. So, how to find out its mean time or expected time. So, as far as activity 1, 2 is concerned, you have got activity 1, 2 and we know that its optimistic time is 3 days, pessimistic time 9 days, right. So, its expected time T E would be, just take the average of these two. So, the formula is T O plus T P divided by 2, right. So, this is 6, is not it. Now, you need to calculate variance of this activity also. So, for variance, first of all calculate standard deviation and the formula for this is T P minus T O divided by 6, right. So, if you look at T P is 9 minus 3 divided by 6, this is 1. So, standard deviation is 1. So, variance is also 1. So, in this way you need to calculate expected time as well as variance of all the activities given in the network, right. So, similarly, since you know how to calculate T and standard deviation of 1, 2, you can do it for activity let us say 2, 3. So, for activity 2, 3, its mean is let us say T E for this is 10 and variance is 4. I am not going to calculate how did I get this, you can easily find out, right. For activity 3, 9, T 3, 9, T E expected time is 12 and variance is 16 by 9, right, or 4 by 3, right. For activity 4, 6, T 4, 6, its expected time is 7 and variance is 1, right. Now, if you look at the activity 5, 8, for activity 5, 8 its duration is fixed and the duration is 5 days. So, for activity 5-8 its duration is fixed, which is 5 days. So, its t is also 5 and its variance would be 0, right, because standard deviation is also 0, right. Similarly, for activity 8-9 T8-9 its expected time t is 4 and variance is 0. Now, since we have calculated expected time and variance of several activities, but we did not calculate so far expected time and variance of those activities for which you have been given probabilities along with their durations, right. So, let us take first activity, which is activity number T14, right, activity 14, right. If you look at activity 14, then its durations are given for activity 14. Look at this. It will take 16 days, its probability is 0.25, it will take 17 days, probability 0.5, it will take 18 days, probability is 0.25, right. So, we will calculate the TE value for activity 14, right, our expected time of activity 14. So, what you can do here is you just multiply the durations and probabilities, right. So, expected time for activity T14 is equal to it's 16 into 0.25 plus 17 into 0.5 plus 18 into 0.25, right. So, 18 is the duration, 0.25 is the probability. Keep in mind that the sum of these probabilities should be 1, right. So, this value is 17, right. So, expected time for activity 14 is 17 days. Now, let us calculate its variance, right, and for variance what you need is this. Since you know this time, expected time, and you have also got the probabilities. So, first of all what you should do, let us calculate standard deviation, right, for activity 14. So, for this you have got duration is 16 days, expected time 17 days, right. So, 16 minus 17 whole square. Then you have got 17 days minus 17 is its expected time. So, again square of this. Then the third duration for this activity is 18 days, right. So, 18 minus 17 whole square, right. So, what we have done, we just subtracted expected time from their durations and we will take square of that value, right. So, if you calculate these values, then this is 1, right, this is 0 and this is also 1, right. Now, after calculating these values, you just multiply these values with the probabilities which are given in the question itself, right. So, what you should do, so let us look at variance of activity 14 is equal to 1 into this 1 into its probability 0.25, right. Then zero into probability 0.5, right, then 1 into again 0.25, right. So, this probability 0.25 which is here, this probability 0.5 which is here, this probability 0.25 which is here, right. So, if you solve this equation, then you will get 0.5, right. So, this is the variance of activity 14, right. This was your expected time. So, this is how you should calculate expected time and variance of those activities for which you have been given durations along with probabilities, right. Similar to this calculation, you can do, you can calculate expected time and variance for other activities. For example, if you look at activity 4-5, for activity 4-5, right, this is, you need to first calculate the expected time and the durations are given like this. So, 3, 4, 5, 6. So, just multiply these two values. So, this is 0.6, this 1.2, this is this is 2, right, not 0.2, this 2 and this 0.6. So, if you add all these values, it would be 4.4, right, this 4.4, right. Now, what to do next? Since you have got mean value 4.4, so 3 minus 4.4 whole square plus 4 minus 4 whole square, then 5 minus 4.4 whole square and 6 minus 4.4 whole square, right. So, you will get 4 different values, right. So, let me write those values. So, this is 3 minus 4.4 whole square, then you have got 4 minus 4.4, then you have got 5 minus 4.4 whole square, then you have got 6 minus 4.4 square, right. So, this is 1.96, this is 0.16, this is 0.36 and this is 2.56, right. Now, since you have got these values, you just multiply these values with the probabilities, right. So, you can just write it like this, 0.2 into 0.3 into 0.4 into 0.1, right. So, if you take some multiplication of all these values and summation of that, you will get that value as 0.84, right. So, this is the variance of activity, this is the variance of activity 4, 5, right. In this manner, you can calculate the expected value and variance of all other activities, right. So, let me directly write the values for other activities. So, similarly for activity 6, 7, right. So, for activity 6, 7, mean is 4.5 and its variance is 0.25, right. For activity 7, 8, its mean is 5.6 and variance is 0.24, right. Now, we have calculated expected value as well as variance of all the 11 activities, right. Now, we will calculate the critical path, right. So, for that you need to draw a network first, right. So, if you look at network would look like this, in fact, it is already there in slide. So, let us look at this, your first event, this is your second event, this is your fourth event, this is third, this is fifth, this is sixth, this is your ninth event, you got 5 to 8, 6 to 7, 7 to 8 and 8 to 9. So, this event is the last event, right, and these are different activities, right. We have got a dummy activity also, is 4 to, in fact, this is like, in fact, it has to be like this, right, 3 to 4, right. If you look at their now you can write their expected values as well as their variances, right, on all these activities. So, if you look at the duration of the project, it would be look like this, right. So, if you look at the critical path, this is your critical path, this 1, 4, 6, 7, 8 and 9, right. So, this is your critical path and the total duration of this critical path is 38.1. So critical path is 1, 4, 6, 7, 8 and 9 and its value is 38.1, right. And if you look at the variance along critical path, variance along this path, so variance, we know that a variance of activity 1, 4 is 0.5. So you just add all those variances. So if you look at the variances, then it is 0.5 plus 1 plus 0.25 plus 0.24 plus 0, this becomes 1.99, right. So when this is the variance, standard deviation is 1.41. So the first part of this question is what? The first part was what is the critical path and what is the duration of this project. So this is critical path 1, 4, 6, 7, 8, 9. This is your total value of the critical path. This is your standard deviation, right. First part we have done. If you look at the second part of this question, the second part is what is the probability that the project would take less than 40 days. Now we know that the probability that the project would be completed in this much time is 50%, right. This is what we have already seen in previous couple of sessions, right. Now we have to find out what is the probability that it would be completed in less than 40 days. So this is your mean value, right, this 38.1, right. And what is the question? What is the probability that it would take less than 40 days, right. So we have to calculate this area, right. Now we already know that the 50% of the area is 0.5, right. So from here to this point is 50%, right. Now we need to calculate only this much area. Now for that you need to calculate Z value, and what is the Z value for this question? So the probability that the project would take less than 40 days is equal to this, right. So this is 40 minus this x minus mu, right, is 38.1 divided by standard deviation, which is 1.41, right. So you will get Z is equal to 1.35. Now look at the area when Z value is 1.35. So I have already talked about how to look at the area under curve. So if you look at Z value, when Z value is 1.35, then that area is this area is 0.4115, this area, right. So we already know that from here to here this area is 50% and this area is 41.15. So the total is 0.5 plus 0.4115. So this is approximately 91%, right. So what is our finding? Our finding is that the probability that this project would be completed within 40 days is 91%. So this is how you can solve a question in which you have got activities having different time estimates. Some of them are normally distributed, some of them have got fixed duration, some of them are dummy activities. So this is an example wherein you have been given 5 nodes and 5 activities. So activity 1, 2 is normally distributed. N stands for normal distribution, right. So this is an activity which is normally distributed, and this is mean and this is standard deviation. So you need not calculate mean and standard deviation separately. So for activity 1, 2, mean is 5 and of course standard deviation is 2, right. and if you want variance is 4, right. 2, 3, it's an activity having 3 time estimates, right. So mean would be what? You need to apply that formula, right. So what is that formula? It's 3 plus 4 into 5 plus pessimistic time 7 divided by 6, right. So this is 7 plus 3 10, 20 30, 30 by 6 means 5. And what would be the standard deviation? It is 7 minus 3 by 6 whole square, right. So 7 minus 3 is 4 by 6, it's 2 by 3, 16 by 9, right. Sorry, it's 4 by 9. Calculate once again for activity 2, 3, it's 7 minus 3, this 4 by 6, it means 2 by 3, 4 by 9, right. For activity 2, 4, which is a discrete activity having different time durations along with probabilities. So the probability that this activity will take 4 days, this probability is 0.1, it will take 5 days, probability is 0.3, it will take 6 days, probability is 0.4, it will take 7 days, probability is 0.2. So you need to find out mean, right, the way in which we have just calculated in previous example. So let me calculate mean first, right. So it is 4 into 4, 5, 6, 7, multiply with their probability. So it is 0.1, 0.3, 0.4 and 0.2. No, it is not like this. It is 0.3, 0.1, 0.3, yeah, it is 10. The total should be 1, right. So this 6 plus 0.4, right. So this is 0.4, 1.5, 2.4, 1.4. So this total is what? 9, 5.7, right. So this is 5.7 is the mean. Variance, you need to again do all those calculations, right. So it's 5.7 minus 4 whole square, yeah, let me do it here, right. It's 5.7 minus 4 whole square plus 5.7 minus 5 whole square plus 5.7 minus 6 whole square plus 5.7 minus 7 whole square, not plus. So just put comma over here. So just calculate all these values and multiply these values with these probabilities, right, and then you will get variance over here, right. This is what we did in previous example. If you take activity 3, 4, it is constant, it has got constant duration 3, 4, its duration is 3, variance is 0, right, because duration is fixed. Activity 4, 5, it is normally distributed, with mean and standard deviation. So mean is this, standard deviation is 2, variance is 4, isn't it. Find critical path and probability of completing this project between 12 and 16 days. So how to solve a question like this? So let us solve this question. So for E1, 2, it is 5 and 4, right, variance is this 2, 3, 5 and 4 by 9. For 2, 4, it is 5.7, right, it is not 5.9. In fact, I must have done some mistake over there, right? It may be correct also, but there is not much difference, right? So it's 5.7 or 5.9 does not make any difference, right? Now the variance is 0.81, right? So this is what I have done there. It's 4.54 minus, no, this is actually, its mean is what? First of all you need to calculate mean. So mean is 5.7. So 5.7 minus 4 whole square, either you write 5.7 here or here, does not make any difference, right? So just add all these values after multiplying with these probabilities, right? So this value comes out to be 0.81, right? And for activity 3-4 its duration is fixed, variance is 0. For 4-5 also it's normally distributed, so mean is 2, variance is 4, right? Because standard deviation is 2, right? So in this way you have got the duration of this particular project. So critical path is 1, 2, 3, 4 and 5, and the total duration is 15 days. How come 15? 5 plus 5 10, 13 plus 2 15 days, right? Now probability that the project will be completed in 15 days is 50%. Now we have to calculate what is the probability that this project would be completed within between 12 to 16 days, right? So that part you need to calculate. What you need to do is, okay, let me do it. In fact, since you have got, in fact you need to know the standard deviation along critical path. So since this is 15, since this is 15, you need to find out this area, and what you need to do, 12 minus 15 divided by whatever is standard deviation along critical path, then z is equal to 16 minus 15 divided by again standard deviation. So whatever is the value here, look at area under curve, whatever is the value here, look at area under curve and add those two areas, right? So you will get probability of completion of this project between 12 and 16 days. So with this, let me complete here. Thank you very much for attending this session. Thank you.